Hello everyone, welcome back to my 100 most popular algorithm series. In this particular video, we are going to take a look at Leetcode problem number 98, which is validate binary search tree. It's again a very popular problem, one of the classics. It's a medium categorized problem and liked by close to 5,500 people. The problem statement goes like this. So here we've given a binary tree and we need to validate that it is a binary search tree. Now a binary search tree is a special type of binary tree where it follows these conditions. So all the left subtree, so for example this is a binary tree. Now this can be a binary search tree when all the nodes to the left of this node should be less than this value, and all the nodes on the right side of this node should be greater than this value. Right, so that is the basic condition, and this phenomenon should be true for all the nodes in the tree. If all the nodes obey this condition, then it's a valid binary tree. So yeah, that's the problem statement. Now the way we are going to solve this is that every node will traverse the binary tree, all the nodes. Now every node will return the lowest and the highest values that is seen at that level. So for example, we are at the leaf node. Now obviously there are no more nodes here to go further. So the lowest and the highest values that is seen here is the number itself, the node itself. So it will return 3 and 3, lowest and highest. It will return to its parent. Now the parent's job is to make sure that whatever is the highest value that is returned from this particular left children should be the highest at this level should be less than this number. So it will make that check. If that check fails, then this will return false, meaning that the binary tree is, this is not a binary search tree at that level, meaning the entire tree is not a binary search tree. So if any of the children returns false, and then that false will propagate upwards till the root. No need to check anything because the binary tree is not valid. If this condition passes, that the highest at this level is less than this number, then the flow will continue to the right on the right side. Now on this node will also return the lowest and highest that is seen at that level, and it will return to this parent. Now parent will check whatever is the lowest that is returned from at this level must be higher than this number. If that is the case, then that is true, well and good. Otherwise it will return false. And if everything is successful at that level, this node's job is to return the lowest and highest seen at that level, and so that the logic will move upwards and the same calculation can be performed by its parent. Great, so that is the high level logic. Now in tree problem, obviously we need one function which will do the recursion. So I'll call this validate, and we will pass a node to this function. So this function will do all the heavy lifting. The job of the parent function is just to invoke just start the recursion, but before that it will just perform this sanity check. If the tree is not present, then that is false, that is not a binary search tree. Okay, otherwise it will call this function and pass the root. Now if this function returns false, which means it's a not binary tree, so we will return false, else we will return true. Right, so the job of this function is over. Now we will focus on this function. Yeah, so here every function or every node, that as I mentioned, the task of this node is to figure out the lowest and the highest at that level. So I'll just initially that will be the node value itself at this point, because we have not really traversed anywhere right now. So the smallest and the largest is the node itself. Okay, so now we will perform the recursion. So this node will first give the chance to its left subtree to give me the smallest and highest at that level. So if we have a left subtree, then we will call this function recursively on the left child. and whatever is the result, we will store it in this variable. Now, as I mentioned, if my left subtree is not a valid binary search tree, this should return false. So I can make that check here. So if not left result, meaning it's a false value, then I'll also return false, because there is no need to go further. My child is not a binary search tree, meaning the entire tree is not binary search tree. So I'll return false. Now here I have to make, if it is true, meaning this is a valid tree, then I need to make that check. So this, in that case, this left children must have returned the lowest and the highest that is seen at that level, and it is in the form of a list or an array, in general terms. So what we can check is, and in this array, the first position will be the lowest and the second will be the highest. So at that level, what I need to check is if the number at the second position, which is the highest number that is seen here, if that is greater than equal to the value at the current level. Now that is a false situation. The highest value that is seen on the left side cannot be greater or equal to the value, my value. Okay, so I know in that case I need to return false. The tree is not valid at this point. Otherwise, if it was successful, if the value is smaller, then that is the smallest. Then we can assign a smallest to whatever is the smallest value that is seen at the children. Okay, because the left child is the smallest, and whatever the smallest that is seen, that will become smallest at this level also. So I'll just do that. Okay, so the left side's work is done. Now focusing on similar thing on the right side. So I'll then call the validate function recursively on the right children, the right child, and if my right child has returned error or false, meaning right subtree is not a valid subtree, a valid BST, so in that case I'll straight away return false. Otherwise, this result would comprise what is the smallest and highest value seen here, smallest and largest value seen here. So in that case, now what check I need to do is, whatever is the smallest that is seen here must be greater than this particular node. So I'll just make that check. So if the smallest value is present at the first index, if that is somehow less than or equal to the node, now that has to be greater. Okay, to be a valid by BST, the smallest value seen here has to be greater than this. If it is not the case, then again this binary tree is not a valid one. Otherwise it's a valid one. So the highest at that level is whatever is the highest at this level. So that is the largest. So I'll just set largest equal to the largest at the right subtree level, and then in the end I'll return an array comprising of smallest and the largest. Yeah, so that should be it. Let me verify my code. Yeah, working fine. Let me try with this example. Yeah, working fine. I'll submit my code. Yeah, it was accepted. So great, that's how you solve this problem. I hope you liked this coding challenge. For more coding challenges like this, stay tuned to my channel, and I'll see you in the next one. Bye.